All right, today we're going to finish up with section 15.5. Yeah, Boyd, what's
I
up?
have a question on the homework, but I think Nathan also has the same question, so I think we should wait until we get to that.
Okay, we'll grab some at the end, I think. Cool. All right, so we're just going to kind of pick up where we left off, and we're going to pose this question. So suppose we have an account that has a 6.5 annual interest rate, compounded monthly, and we want to know what the equivalent interest rate would be for an account that's compounded annually. So we know we're going to be doing a compound interest situation, so we're going to be using this formula. So our monthly, if I fill in what I know, it would be that. And if it's yearly, right, that's the same as annually. If I fill in what I know, it's not much. Right? But what I basically can do is, if I just take those pieces and set them equal to each other, everything else is the same, right? Yeah. So if those two pieces are equal, then I would be able to find the interest rate that makes them equal, right? Find the R that does that. So let's go ahead and do that. I'm going to rewrite 12 times 100 as 1200. And since that's all to the first, I'm just going to drop the exponent there. So I'm going to take that, and I'm just going to subtract 1 over, and then multiply by 100. And that should give me my value for R. Well, just type that into the calculator. So I got about 6.697, or about 6.7%. And now this idea of, okay, what is the equivalent like annually compounding interest rate? Is a concept that gets a name. We call this the annual percent yield, which I think is the same thing as an APR. If you hear those in advertisements for like car commercials and stuff, probably. So it's just a way to kind of compare two different loan offers or investment offers that have different compounding periods. It's like, well, how do I compare these two things? It's a little bit difficult. If I convert them both into a annual percent yield, then it makes it really easy to compare, because whichever one is the bigger one is the more favorable one from an investment side, or in a loan situation, whichever one is the lower one would be the more favorable value in the loan situation, right? I think, Dewan, you were asking about APR the other day. So that's the idea. Just like your loan may have some really weird terms to it in terms of like how often things are compounding. The APR just converts it into like an annual percentage so that it's easier to compare to other loan offers, is the idea there. Okay. So here, as an example, it says which one of these offers is the better investment. We have 7.8% compounded quarterly or 7.65% compounded weekly. The idea is we're just going to convert both of these into APR or APYs. And we'll just compare the two numbers.
That'd be 400.
Oh, thank you. Yes. Boy, that would have been a crazy number we would have gotten out of that. So let's go ahead and just kind of bang this through on the calculator then. So the first one is about an 803% yield.
How do you do that big
It just, because I did a double. I did a parenthesis, then a parenthesis. It made it big because I had where the exponent is, I think. It just did it automatically. I didn't do anything to do it. I just typed it in like it would look on my calculator, and it just sizes the parentheses so it's easier to match them. And the other one's a 794. So which one would I want? The bigger one, right? That's my better offer. So we've talked about like investments here now, right? What we're going to talk about next is something called an annuity. So let's define what we mean by an annuity. So an annuity is an account into which a sequence of payments are made. So that could be like a retirement savings account where you're putting the same amount of money into your savings, your retirement fund every month or every paycheck or whatever. Or it could be like a loan situation where like you borrowed some money and then you're having to make regular monthly payments on it. An ordinary annuity is an annuity that always makes the same deposit at the end of each period that the interest is calculated on the account. So most of the things that we would do would be ordinary annuities, whether you're saving for retirement or you have a loan. Typically, you're making the same payment over and over and over again. The future value of an annuity consisting of n ordinary payments of PMT dollars at an interest rate per compounding period of I is FV equals PMT times the quantity 1 plus I to the n minus 1 all over I, where I is R over 1,000, or I'm sorry, 100K. So that R is the interest rate, K is the number of compounds, and cap N is just K times N. Again, K is the number of compounds, and lowercase n is the time. So let's look at a couple of examples using this. So it says at the end of each quarter, Sarah makes a $500 payment into an annuity account. So right there, we know that we're going to be using this annuity formula. If her investment earns 7.88% interest, compounded quarterly, so this is like my R, that's my K, this is my lowercase. What will the value of the annuity be in 20 years? That's my lowercase n, and obviously the 500 is the payment. So we have 500 times 1 plus 7.88 over 100 times 4 to the 4 times 20 minus 1 over 7.88 over 100 times 4. So that's kind of a mess to type into my calculator. I think the easiest way to do this is I'm going to do 7.88 over 100 times 4. And I'm going to store that as a letter. I'm going to store it as capital I. So now I'm going to do 500 times, and then I will do the fraction, parenthesis 1 plus that capital I to the n is K times little n minus 1 over I. So I come out with $95,483. And some pennies, 39 cents. Is everybody okay with that? Yeah. And I strongly encourage using that store option where we're going to store the I value into a letter. It makes it just a lot cleaner to get into your calculator that way. You could do the fraction command inside of the fraction command if you wanted to, but that can get a little bit hinky trying to get that in your calculator the right way. Where if you store, that letter I into a variable, it makes it a little bit nicer to do that. Okay. So what if we wanted to do the reverse? What if we wanted to figure out the payments needed for a loan? Let's look at that kind of situation. So we say the net or total amount of money borrowed for a loan is called the present value or principal value, which we abbreviated PV. The PV of a loan consisting of n equal payments of PMT dollars at an interest rate per compounding period of I is the formula PV equals PMT times the quantity 1 minus the quantity 1 plus I to the negative n all over I, where little I is R over K and cap N is K times little n. So it's just like the formula before, we just rearranged it a little bit. Let's do a numeric example so we can kind of do this sort of thing. So here we have a fairly common real world situation. So Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes a $2,000 down payment and the interest rate is 2.9%? So 2.9 is my I. 12 is my K because we're talking about monthly payments. Little n is 48 because we have monthly payments. So we have oh, I'm sorry, I don't need, little n is just 4 because we're going to do K times 4 anyways for cap n. My apologies. And the PV is going to be not 1850, not 2000. So it cost 18,000, but we paid $2,000 down.
16,500.
Yeah, so it's going to be 16,500 because that's the amount we actually had to borrow. So all I'm going to do is divide this stuff all over to the other side. So I'm going to do a couple of stores, or I'm going to do a store on the I again. So just like I did before, 2.9 divided by 100 times 12. And we'll store that into a letter. I'm going to store it again into I. And then I'm going to do 1 minus 1 plus I to the negative 4 times 12 over I. And I'm going to do then 16,500 divided by that answer. Oops. So when I do that, I get 364.49. So you're paying about $365 a month for your car payment. So I think that from the consumer perspective, the next obvious question is, well, I get that Maria borrowed $16,500, but how much did she actually pay for that car? Right? Because we paid $2,000 right away, and then we did 48 payments, and each payment was $364.49. So let's see how much we actually ended up paying for this car. I think we're going to be kind of sad about the answer. So we actually ended up spending $19,495.41. Oops. Yeah. Yes. Oh, sorry. I was writing the wrong number there. 495.41. Now I use the ants there. I probably should have just said, yeah, 2,000 plus, yeah, 364.49. So that's, yeah, which makes sense, right? If you're paying like an extra penny that many times. So that's the difference. Okay, so that's not a big deal. So what did we actually pay in interest then? So this is the total cost of the car. Before we do that, what's the total cost of the loan? That would just be the cost of the car minus the down payment, right?
Yeah, so that's 60.
Well, it's 17.
And that's-
Yeah. And then the interest that we paid would be the $1,650 minus that number, right? So $995.52. Everybody's okay with that? And that kind of concludes chapter 15. I thought there was another thing to do here, but that's it apparently, which is not bad, right? Now, Boyd, you said you had some question or questions.
I did.
You wanna, let's do a couple of those now, and if we still need to, we can come back and do some more after lunch.
138.
138. Oh,
Create choice. That's the one I was reading too.
yeah.
Yeah, dead body.
Okay. Yeah, for all our CSI fans here.
Yeah, it's quite the block.
All right. Detective finds a murder victim at 10 a.m. The body temperature is 91.5 degrees Fahrenheit. 1 hour later, the body temperature is 90.2 degrees Fahrenheit. If the temperature of the room was held at a constant 70 degrees Fahrenheit, approximately what time was the person murdered? The average human body temperature of a living person is 98.6. it says use Newton's law of cooling twice and combine the equations to solve for K. So let's remember what Newton's law of cooling's equation was. Yeah, I'm gonna just look it up so I don't, last thing I want to do is goof up the equation, because that's would be a tragedy. T of t equals T sub m plus T naught minus T sub m e to the negative kt. Okay. So let's start filling this in. We have the data point. I'm going to call it 0, 91.5, where t is going to be the hours after 10 a.m. Everybody's okay with that? So if I have that, and then I would have another data point, 1, 90.2. We know T sub m is 70, and we know T sub naught, the initial temperature, should be 98.6. So what I'm going to do is I'm going to use this. Let's think about what's going to be the easiest way to do this. There's two ways I could do this. I'm just trying to think for a moment and see if okay. Okay. I think the first step, I'm just going to treat, since I know that K is a constant, I'm going to treat this as kind of a T naught, and I'm going to treat this as like T of 1. So I can say 90.2 is equal to 70 plus 91.5 minus 70 e to the negative k times 1. So I'm going to solve this equation now for k. So I'll subtract the 70 over. You could do this by graphing also. I'm going to do it algebraically just for grins. Then we'll divide both sides by the 21.5. To cancel out the exponent base of e, we'll do the natural log of both sides. And then we'll divide by -1. So that's my K, about 0.0624. But I'm going to store this now because I'm going to use this in a moment. I'm going to store this as K as soon as I find the K in my alphabet. There it is. Okay, so that's like step 1. We found K. Now we want to find out how long this person has been dead, right?
Yep.
So what I'm going to do there is I'm going to treat T naught as this, and then I'm going to call that 10 a.m. time T comma 91.5. So I'm going to do the same thing. I'm going to have 91.5 equals 70 plus 98.6 minus 70 e to the negative. I'm going to write the letter k there because I'm going to use that stored number from before. So I have this. And I'm going to solve this for t. So again, I'm going to do this algebraically. You could, if you wanted to, do this graphically. Again, it's just for grins that I'm doing this. So divide by 28.6, do the natural log of both sides, and then divide by negative k. I'm going to do that all on one step. Mostly because it's all going into my calculator anyways. So negative 1 over k times the natural log 21.5 divided by 28.6. So I have 4.575. Oops. No. Yeah, so this would be hours before 10 a.m. So let's see. Yeah, it was early morning. That makes sense. So if I subtract 4 off of this, we'd be at 6 a.m., right?
Yeah.
And if I take this 0.575 and multiply it by 60, that tells me it was 34 minutes. So it'd be like 5:26 a.m. And I think that'll do it. Let me just check my answer key for the evens to make sure that that is what they get. This was 38, 138?
Yep.
Yeah, good. That's what I got. Boyd.
So, how did we get the negative 1 over k after last step?
So after I do the natural log, I'd have negative k times t. So to get the t by itself, I had to divide the negative k over. So I wrote it as times the reciprocal instead of division. Is that okay? I think it's lunchtime here, so we'll pause this. And if you guys got more questions, we can deal with those when we get back. I was going to do that on Monday, but we do need to talk a bit about homeworks, right? About what's due and when and
When, where, why, how?
yeah, when, where, why, how, all that jazz. What have we assigned so far?
We're up to 150.
150. Okay. So the new stuff then, we have done enough to finish this out, which goes all the way to 184. So that assignment there won't be due on this weekend. It'll be due next weekend. I think it's the 21st is next Sunday.
Yeah.
So that's part of Sundays. And then what have we collected so far? I gotta pull this up real quick. I don't even remember anymore.
It's 131 to 150 due this weekend.
Yeah, okay. So we started 130. Okay. So for this weekend,
Oh my god, I just saw that.
131 to 150. That feels pretty doable. And then I guess There's no point in not just saying plus the review there.
Yeah.
So we'll take Monday as the review day, and then we'll do the chapter test Wednesday next week tentatively, and then we'll Friday we'll kind of figure it out.
I'm actually sick.
What?
Already?
Yeah, it's in my calendar. It's sick.
Man. Oh, I forgot to grade that Delta Math thing.
When is our test gonna be, you said?
Potentially Wednesday. That's the plan right now. Yeah, let's get that
I would
in
really,
there.
really rethink your decision that sushi hamburger with no tomato. A sushi hamburger with no tomato.